This is the CBSE IIPMT 2012 question. The question is like this. The motion of a particle along a straight line described by the equation is this. Displacement is given for you, where x is in meters, t is in seconds obviously. The retardation of the particle when its velocity becomes 0 is. So from this you have to find out where is velocity, what is velocity when it becomes 0, and then what is acceleration at that instant. So let's see what is given for you. It is given that displacement x equal to 8 minus 12t minus t cube. How can I get velocity from the displacement? Velocity is defined as rate of change of displacement. That means I shall differentiate this displacement with respect to time. Differentiation of constant equal to 0. Differentiation of 12t equal to, sorry, it was given plus here. I have written minus by the mistake. So plus 12. Differentiation of t cube using a formula. Differentiation of x power n equal to n into x power n minus 1. So differentiation of t cube means power I have to write first as per the formula. Power minus 1, that is 3t square. So differentiation of t cube is 3t square. This is the velocity. Now you want acceleration, right? What is an acceleration definition? Acceleration is defined as, again, rate of change of velocity. Once you got velocity equation as 12 minus 3t square, I shall differentiate this once again with respect to time. Yeah, differentiate that again. Differentiation of 12, a constant equal to 0 minus 3 to differentiation of t square. So here I have written for t cube, let's write for t square. N into x power n minus 1. N is 2, x power of 2 minus 1, that is 2x. Sorry, 2t, because this is given as. So 3 minus, so 3 into 2t. That is, acceleration is minus 60. What is the value of this time? For that he has given a condition for you. What is the retardation when the velocity of the particle becomes 0? I know the equation for velocity already. If this velocity becomes 0, 0 equal to 12 minus 3t square, then 12 equal to 3t square. That implies t square equal to 4. That implies t equal to 2 seconds. So when velocity becomes 0 is the time of 2 seconds. As you want retardation when velocity becomes 0, in the place of the time when velocity becomes 0, time has to be written. That is 6 into 2. That is the acceleration is minus 12 meter per second square. That minus is not available in the options, but he has mentioned it as the retardation, so he need not mention that minus. So your answer shall be acceleration is minus 12 meter per second square. When you say retardation, it's a negative acceleration, so I need not mention negative again. So your answer becomes 12 meter per second square. That's the answer for the problem. So to solve this problem, we have used a basic concept that to get velocity, we shall differentiate displacement once. To get acceleration, velocity once again, that means displacement has to be differentiated twice to get acceleration. That's an important point I want you to understand. Velocity dx by dt, acceleration dv by dt, that is d by dt of, in place of v I can write dx by dt, that is d square x by dt square. That's an important point. I want you to understand that displacement has to be differentiated twice to get acceleration and only once to get velocity. That's the point I want you to understand. That's it. Thank you for watching.